Hello guys, welcome back to Tronics Energy. We want to start another series of making a brain. The brain is going to be powered, or is going to have, or is going to be controlled by logic rather than having a microcontroller, because I don't have microcontrollers and Arduino and all those stuffs, but I'm going to make it out of logic only. We're going to push our limits to check how far we can go in making the brain more brilliant and intelligent as we can, compare or as using the supplies that we have. So right here is the building blocks of the foundation of the brain. So this is a single memory cell. It's an SR latch circuit. So an SR latch circuit is a set reset latch circuit. It's basically a circuit that stores a bit, one single bit, depending on how many you've connected. So for mine, it's only going to store one single bit, and it has a set if you want to store, and it has a reset to clear what you had before, and yeah, for you to input the new data. So right here we have the circuit, and I'm making it using NOR gates. You can make it using NAND gates depending on how you want your circuit, but right now I'm using a NOR gate. So this is the NOR gate connection. I don't have an OR gate IC, but I'm using an OR gate. This is an OR gate. Then I'm going to invert the output of the OR gate to get the NOR gate. So this is an inverter. It's an X inverter, and this is the OR gate 74LS32. So this right here is an X OR gate. It's just a feature that I've added to this circuit to make it more maybe fun, let's say fun, because for the SR latch circuit you only need two NOR gates just to make it. It's just a simple circuit, but I've added another cool feature right here that I'm going to explain in a few. So how does the SR latch circuit operate? So right here, I hope you can see right here we have the two NOR gates. So if A is on, it's going to come and enter this first NOR gate. And how the NOR gate operates is if either of the inputs A and B are on, or if both of them are on, is going to give a zero output. The same as the other one. So if both of the inputs are off, is the only time it's going to give a one output. So if I press A, then A is going to come, is going to have it's going to be an input. So this part is going to be zero at that point. That zero enters this second one, and the other input of that second one is still off. So meaning that this IC will give a one output because both of the inputs are off. Going to give a one output. So that one output is going to come and it's going to power this one. Let's go to the next one. If I power the next switch, then this one will be off. So we turn the other one off and we turn the next one on. So this one is going to be off. Both of the inputs are going to be off. So it's going to give a one output. That one output is going to come and enter this one. Once this one records that if either of the input is 1, is going to give a 0 output automatically. So in the next phase, it's going to turn on this LED. So it's just like shifting either of the two circuits. So right here, now let's explain the feature that we have added using the XOR gate. So the XOR gate right here, you can see it takes the inputs both A and B. Just this is a correction. This is not a connection. The connection should start from this point onwards, not from this point. So this is an XOR gate, and it has taken the inputs both A and B. And how an XOR gate operates is that if both of the inputs are alike, meaning that if both of them inputs are on or off, then it's going to give a 0 output. And that output is the one that controls these transistors right here, which control the LEDs. So if both of the inputs are off, then it's going to give a 0 output. That 0 comes and enters the base of these transistors, meaning that it's not going to allow the LEDs to light. If both of the inputs are on, it's still going to give a 0 output. That 0 comes and cannot power these transistors, meaning that these LEDs will still be off. if either of the inputs are on, if either A or B are on, then it's going to give a one output. That one output is going to turn on the LED which should be on. So what's the essence of this feature? If you can just experiment yourself, or if you've already seen it yourself, the set and reset latch circuit and usually has default state which is undefined. If you put both inputs on or off, then you don't know if it's going to be on or off. So to minimize that that confusion or that configuration, I've set the default state. So the default state of this circuit is always off. So right now the circuit is on, but you can see both of the LEDs are off. If I turn on this first one, then I've turned on the set. So this is the set. If I turn on the second one, then it turns off because both of the inputs are on, so meaning that it goes to default. If I turn on off the first one, then it goes to reset. So this is basically how the circuit, the feature is operating. So this is basically how a set reset latch circuit. So you set with the first one and you reset with the second one, like that one. So if both of the inputs are off, then it goes to default, which is 0, always 0. So this is basically how this circuit operates. And next time we are going to add a 74LS195 because that one is much more bigger than this one because it can store a maximum of 4 bits. I'm going to add either 2 or 3 of them depending on how much memory I want my brain to have. So I hope you have really understood how a set reset latch circuit operates, and how if you like this cool feature, you can still add it to your circuit if you want to make it more better or fun to experiment with. So thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time when we are going to add another we're going to make our brain more bigger in terms of size. And yeah, so hope to see you next time. Goodbye.